So yesterday morning I got back from a trip to Utah and I checked the weather and saw that there's a big cold front headed our way. And I thought, since we're talking about cold fronts in class, I'd do a time-lapse photo of what that actually looks like. The changing conditions when you get a cold front coming your way, and what that actually looks like when you're on the ground witnessing this cold front. So I set up a video camera at my house and put it on time-lapse mode, and I also set up a little weather meter next to it so that I could capture some of the variables, so we could look at, what the changing conditions are when you have a cold front passing. So in the next video, I'm going to show some of this data and video footage that I collected yesterday, combining some maps from NOAA showing where this cold front is, along with the data collected on my patio and the video from my patio. So this first map shows the situation at 5 o'clock in the morning local time. There's a pretty clear cold front. It's north of LA at this point, but you can see that blue line stretching across. That's a cold front. Those blue triangles extending out from the cold front indicate the direction in which the front is traveling. So we have cold air moving down towards us here in San Diego. And San Diego is, of course, where the border is. So where that black line meets the coast, that's about where San Diego is, and where I made this video is Oceanside, so just up from that. For each of these weather stations, the current temperature is towards the top left of the station, and it gets a little bit confusing in busy areas like the San Diego area. But you can see a couple red numbers that show like high 40s and up to 53 in the area. These surface maps are produced every 3 hours, so the next one that came out is for 8 o'clock in the morning, and you can see that the cold front has moved forward a good amount. So right now it looks like it's over LA, over the Channel Islands, but it still has a little ways to go before reaching us in San Diego. You can also notice, because it's later into the day, between 5 a.m. and 8 a.m., it's warmer in the San Diego area too, so those temperature numbers have gone up. By 11 a.m., the front's really moved forward quite a bit. It's no longer over the Channel Islands, and it's threatening the coast of San Diego. And since we've gone from 8 a.m. to 11 a.m., we've seen some of those red numbers, which are the current temperature in that place, jump quite a bit. So we see 56 and 59 there now, and as before we saw, high 40s to low 50s. Once the front passes, we're going to expect those to change. So in the next time period, we're going to actually see the front having moved past those areas or be hitting those areas, and the temperatures should change quite a bit. In this final map showing the surface conditions, we see that now the cold front's moved inland a little bit, especially in North County, San Diego. It's pretty much hitting the coastline right at the border, closer to downtown San Diego and Tijuana. But you can see a clear change in temperatures with the arrival of this cold front. So those red numbers now in the San Diego area are in the low 50s again. So remember, one place it got up to 59 just earlier in the day, and it should be getting warmer by 2, but it actually got colder because of the arrival of this front. So in the next little bit, I'm going to show what this actually looked like. I captured video from my patio from about 9:30 to 11:30. So essentially from the second map we looked at until the arrival of the front. Unfortunately, the camera stopped collecting the time lapse right basically when the front was hitting. So near the end of the time lapse, you'll see the front hitting when we get that drop in temperature, but we also get an increase in dew point and in relative humidity. So with the front, we get that rising air, increase in moisture content, and saturation of the air near the ground. So this time lapse starts around 9:30. You can see the time in the bottom right, and it's kind of ticking quickly through minutes and hours, and it lasts until about 11:30, a little after. And that's basically when the cold front arrives. So you can see that it's kind of, stormy conditions leading up to it, but there's a bit of a crescendo as we get near the end. We'll look at some of the data related to this to make it make more sense, but here we are at 11:20, getting near the end. You can see some more clouds and some more activity going on. So right next to where I put the camera, I also had a little portable weather meter that was recording temperature, humidity, pressure, dew point, all of these things while I was recording that video. Now the total extent of data that was recorded is a little bit longer. So I had from 9:30 to 1:30 because the camera malfunctioned at 11:30, the data kept being collected. But these data show that the front did indeed pass around 11:30. So here we have temperature, where you can see a pretty substantial dip in temperature right at 11:30. That max value of 59 is Probably a mistake just because the weather meter might have been warm when we started out, but you can see that there's pretty consistent values around 54, 55 degrees early on before the front arrives, and then it drops to lower 50s after that, where it stays quite a bit cooler for a while. And then there's dew point temperature. Remember that dew point temperature, even though it's expressed as a temperature, is really telling you how much water vapor there is making up the air that's around you at a given point. With the coming of the front, again, this is an oceanic, maritime air that's coming our way. We see a large increase in the dew point temperature. That means that there's more moisture in the air coming our way. And that grows significantly from when I started tracking this data at 9:30 until 11:30. At that point, right when the front arrives, there's kind of a quick dip or divot or decrease and a brief increase, but then it starts tapering off as after that front passes as we get further away from the front. And we get cooler air that can actually hold less water, or contains less water. Putting those last two variables together, we get this measure of relative humidity. And this one, if you remember, tells you how close the air is to saturation. So for any temperature of air, that air can only be made up of so much water vapor before condensation occurs. And when you get to that maximum amount of water vapor in the air, then you get to 100% relative humidity and condensation has to occur. So what that means is if we get close to 100% relative humidity, that means there's so much water vapor in the air that the air basically can't contain more water vapor in its, again, water in its vapor form. It has to condense into its liquid form, like a cloud or fog. And looking at this graph, we can see that, putting together those last two graphs, if, temperature's decreasing, that means the air can hold less water, and the dew point's increasing, meaning there's more water vapor in the air, that means relative humidity is going to increase. And here we see consistently increasing relative humidity. And in this case, it actually maxes out, it looks like, after the front passed around 11:30. But you see a consistent increase as the front gets closer due to the increasing amount of water vapor and the decreasing temperature. So you see that the air did reach 100% relative humidity. So the air was saturated at some point during the passing of this front. That means that there was probably fog on the ground or a cloud at ground level. This air was maxed out in terms of how much water vapor it could have. Finally, there's atmospheric pressure, and there weren't huge jumps in atmospheric pressure here, but you can see some changes. Generally, pressure was lower before, and then right when it looked like that front passed, it kind of bottoms out and dips again before becoming higher again. So generally, cooler air is related to higher pressure. So after this front passes, we get that cooler air. We see higher pressure there. And then again, also around 11:30, we see that drop in pressure as the front actually passes because we have that rising air at that point.